Okay, for my numerical calculation reassessment, I chose a question that was similar to the one like we did in class. So the dropping a ball question. So a ball has a mass of 0.8 kilograms and is released from rest at a distance of 12.4 meters above the floor. How fast is it moving right before it hits the ground? So if you wanted to solve it on paper, you could use the work energy principle. And first you would draw the free body diagram, which the only force that's going to be acting on the ball is going to be the force of gravity. So then you could use the work formula of work equals the force times delta R times the cosine of theta equals mgh. And then from there, the work formula would equal the change in energy equals, the kinetic energy equals K2 minus K1, which is, the kinetic energy is 1/2 mv squared, the final minus the initial, which is 0 because it starts at rest. So then if you set it equal to this equation, you would have mgh equals the final 1/2 mv squared, and the velocity, if you solve for v, the masses would cancel, and velocity would equal the square root of 2gh. So from there you could check your answer in Python, which I did here. So we see the first one is the graph of the height and the time. So let's see, there's going to be everything for the graph, line 3 and 4. Line 5 is going to be the gravity of 9.8, and then 6 is going to be the distance of 12.4 meters. 7 is going to be the mass of 0.8 kilogram, and then the initial velocity of 0, and time is 0, and the change of time is 0.1 seconds. So for line 13, we have, well, y is greater than 0. This is going to be true. So the acceleration is negative 9.8, which is gravity. Then you can use the formula velocity equals the velocity times a delta t, and then put those in, and then you would print the final velocity from here, and then the final velocity shows on the graph as being negative 15.582 meters per second. So that's the first part. So let's see, after that we could do it in another graph. The energy in joules over the height in meters. So same goes for here, we have everything. Lines 3 through 5 is the graph, and then 6 through 9 is going to be the same information as above. 11 through 13, we have the time, change in time, and the work. 15 is going to be gravity again, then you plug in your formulas. And let's see, we're going to print the final velocity again on this graph, and here it's showing it's negative 6.86 meters per second, which if you worked out on paper equals the same.